Oh, but yeah, okay, fine. Leetcode is. This is why I stopped doing it, I suppose. Okay, let's try this one. I know only 22 people got in it, but maybe they spent a lot of time in Q1. What is this? Okay, let's see. Or Q3 rather. Same thing, I suppose. And most one trade queries. Maximum number possible after making optimal trade on this. Okay, so you try to solve it for a sub problem. Okay. I don't even feel like doing this anymore, honestly. It's just so tiring that, you just keep on getting these problems that are trivia because they ran out of things to have contests on. Okay, so what is the idea behind this one at all? Some people got it kind of quickly, honestly. But, trying to think whether it's I mean, we have the idea from, was it Q2? And Q2 is right, so I guess that's nice. So the idea is that it's the 2 splitting thing, right? So just max 0 from, yeah, min 1 in the and you could answer all of these in pretty straightforward time, right? Because yeah, you get the subsections and then you get the answers. It's just a lot of work. Even Q2 was a lot of work. So okay, so you get the ones, okay, that's fine. Get the zeros, that's also easy. And then it's just doing them at the same time. And that you could pre-process, maybe? I don't think this is that bad though. I don't know why only 22 people got in it, honestly. Or maybe, I don't know, maybe a few more. It's actually surprising. Actually, a lot of people got it. Why does this show 22? Well, okay, maybe I'm like double that, but I don't think it's easy, but it's not, it doesn't seem difficult. Maybe Q3 just trip people up. It's very annoying to get correctly though, for sure. It's just a lot of pre-processing and making sure that you're right. Okay. Yeah, okay, so prefix sum on S maybe. I want to write this. Yes. Oops. Okay, and then now we want not quite prefix sum, but we can definitely do a segment tree E thing on it. It's just Yeah, okay. I mean, okay. So we binary search on the i's and then the zeros and we're fine. Okay, I mean this is just case analysis, a lot of it, but okay. So just prefix, keep track of where the ones start, and then yeah, and then we also just keep track of counts, right? Yeah, I should do this. Yeah, I mean, okay, I just put a segment tree in it. Where's my segment tree thing? Probably don't actually need a segment tree, but I could do whatchamacallit. Binary index tree, that's the word I was looking for. Alright, let's do that. I mean, I have a template for it, I'm too lazy, so okay, fine. No, that's not it. I mean, that is a binary index tree, but that's not the one that I want. I mean, that's fine, I think. Instead of total, we just get max. Okay. Yeah. And then now we have say n. Oh no, we do need a segment tree because it's not prefix. Larry, what are you doing? And then now what we want to do then is can we do that? Okay. I mean that says yes. It goes over. I guess that's fine. We can just do the math. Maybe. What is n? What is m? No, there's a starting value. That's kind of awkward. I have so many different templates. I forget which one's which anymore. But okay, fine. This is a z. This is a one indexed one. Yeah. Where's it? Current. And then T. Yeah, okay. So now we have the segment tree set up. We also want to set one up for zeros. Whatever. added, I think. It's not quite right. We have to handle the edge cases very awkwardly. But that should be fine. Maybe. Yeah, it's just case analysis. So there are two problems we have to solve. So this one is just case analysis. And then the other one, we would have to create another thingy. Yeah, I don't think this is that bad. I mean, it's very time consuming and I am definitely not doing it in 10 minutes. But, just super annoying. Leetcode really has fun of ideas, and also this is okay. So then now that's not quite right. Because this doesn't give you, it gives you the max, but it doesn't give you the index, which I kind of, for some reason, thought that I could. So this isn't quite right. This isn't quite right. We need to know the indexes. Binary search gives us the range. Maybe. It gives us the real, unquote, the real range that we can search by. Right? And the biggest thing that's inside, that's fine. But it still doesn't address the edges, literal edge case. This is a very annoying contest. And I don't feel like I'm learning anything. I'm just kind of, it's a very implementation heavy contest. I mean, I guess the reason is so that Leetcode can beat the ChatGPT but it's just not enjoyable. I don't think there's anything super weird about it. Maybe I am underestimating this one though. I think the ones we can do with something like this, just do a binary search and then do a segment tree thing. The zeros, I don't know. Or the zeros after that, I don't know. How do I handle the zeros? Okay, so the zeros, you can just do the same thing and then handle the edges directly. Okay, that's fine. So you're breaking down the two cases. Okay, okay. Maybe that's fine. And then you have to handle the edges. Okay, okay. That's right. That's why I have the once thing. Okay, so for this is, it's just that there's so much work. We have 5 minutes when I close, but it's fine. Let me take a screenshot of it. Nope. So this is gonna find us the first one, but we don't want it to be on the L, because if it's on the L, you cannot match, right? So it'll be L plus 1. It's on the O. Then we want this like -1 or something, right? We want I think this is roughly right. I don't know if it's right. And then so these are the boundaries of the ones. This is the last one. And then, so then 1 left is equal to, well, just 1 sub L index of, no, that's fine. And then O right is equal to 1 sub L index. So that's the, okay, so we 5. We get the last one. And then we get the length of that one, right? Yeah, we want the length of this one. With extend, go low. We do want the length. And then the length row. Okay, that makes sense, fine. So then it's this plus T maybe, right? So, oh, is T being, that's the current index and that's the right index, so it's 0 plus. Okay, so then if O of right is greater than R, then we have to go back one further. So and then now we can just segment tree query inside that one. Okay, it's fine. What was it? The function max, and this is 1 indexed. Oops. Oh, left. Oh, 1 right. Oh, I always forget the exact syntax. Okay, so that will give us the and also we want to maximize this. Oh, we want min for. Yeah, we want min. Whoops, that's fine. That means we need 2 trees. That's all. No, don't change everything. I think this is roughly right. It's a little bit awkward, but okay. So best is equal to, what I have here. It's the number of ones in the area, right? And that we can do actually by prefix sum. Okay, fine. Right. And here now we, yeah, if we have these two things and it is just, okay. Okay, right. I wonder if there is a simpler problem or a solution. Okay, so this is not done, but this will give us an idea. And then we just have to process the other thing. We want this to be prefix min anyway. But, st. Oh, I call it seg tree. Why do I call it seg tree? Index, right? So, okay, so if there's no ones in the index, then we're just really sad. Yeah, whatever, we'll just write it this way. This may also time, but, oh. Yeah, I don't think, okay, that's actually not great. Did I miss something up here? Oh, this is a string. Oh yeah, I can change it. Memory limit exceeded, huh? Can we not construct a segment tree for that many elements? Am I just... What? Really? Huh. What am I memory limit exceeding from? Maybe I'm done with today. Maybe I'll have to come back later. These problems are silly. Why am I getting memory limit exceeded? Oh my. Just let me test my stuff. Okay, so there's something here. Why? What is making things That's weird. Okay, so that means that this query is infinitely, which is fine. Did I mess this up? I always forget. So this is recursively going too much. I is 1 indexed, so this should be right. I mean, clearly I'm doing it wrong, but does a recursion go wrong? Is it just the min? Because that's the one that I changed. Nope, they're both the same. Even my segment tree today is just not playing nice, and everything is wrong. Everything is wrong. Yeah, okay. Maybe I need a better segment tree setup. Okay. So clearly it is, I mean, this should be returning, right? Yeah, why is this not, I guess this is not returning. But why is that doing that? Left, right, TLTR. The TLTR is wrong. Why is my template so bad today? Well, what am I doing wrong? I don't even want to debug this. I already have too many things to do. Alright, let's see. I'm just gonna ask ChatGPT for give me an actual one. I don't know. Today maybe it's just because I already ran out of time. It already, yeah, I don't even have the leaderboard thing anymore. So yeah. I'm too tired to debug it, I think, but how do I copy this? Okay. I thought there was used to be a copy question. Alright. There's no building. Oh, it's query. Okay. So update is index value. Okay. Update index value. And then query is left right. Okay. There yeah, their thing is way cleaner than mine, but okay. Hopefully this at least gives us some answer. I mean, it's not going to be the right answer, that's fine. But, Okay, we always want this. We always want. Okay. This is not quite right. Why is this not quite right? Because this should at least give me 1, 0, 1. Huh? Do I not even know how to do prefix sum? It's possible. Yeah, so 1 minus 0, right? Zero, 1, so r plus 1 minus. I don't get it. Is it because it does this thing and then gets it wrong? Well, yeah, maybe. I'm just really bad at stuff right now, apparently. Okay, there you go. It's not right. Okay, so the only thing is that the max, we still have to get the thing, right? So we have to kind of add another case for the max 0, which is at the borders. Yeah, but this only happens if a 1 exists, because otherwise we cannot make a move at all. So this still has to be inside here. And then, oh, okay, then we can just, the number of zeros at the edges is just, we also do another binary search. Actually, it's just L index, right? So once start left is equal to once L index, so this is the start. So then this minus L precisely will be the number of zeros. So zeros left. And then all zeros right. How do I do zeros right? Is it? I always don't know that I get typos on zeros. It's also the same of this. So okay, so that's the last thing. So then now r minus this is going to be, maybe I'm off by 1 here, honestly, but I am lazy. We should actually pre-cache all these things, but so we're a little bit closer. I mean, I don't know what that means, but this one for 0, 3, we moved. Oh yeah, we don't do the thing, so I think that's fine, because it removes the 1 and then adds the 2, so it has 2. Okay, I mean, this is maybe what we expect for this input and attempts, and then now we have to kind of do it again, but we have to do one more thing. We have to pre-process this. Okay, fine. Okay, 1 min is equal to this thing. Let me optimize this. Zero max is equal to is it 0? So I don't know. And then now we can just say I mean, it's this, but it's not quite, because this has to have at least one. Yeah, for the one. Yeah, so I think this is all related, because you can't swap without it. Okay, fine. Something like that, right? Okay, I mean, it's not right, but I think it's what we want as the edge cases. And then the other thing is doing it within the same one, right? Which we have to process another thing for, possibly. Yeah, I mean, I think that's fine. It's just more work. I don't know. Watch this like a bad case that I didn't consider. It's basically this part, I suppose. Yes, I could have just copied this. But then now we want this thing. Right. Right. Now if it's a 1, then we want to merge these, and that's fine. And what we want to do is it's just so annoying to code. I don't even think it's that hard. Do I want another segment tree? I guess so. We want to max this time. It's something like this, actually. Yeah, okay. Actually, I guess I could put this here. And that's the replacement tree. And then the query is also still tricky. Is current the right price? Actually, I don't know. This one we just don't care. So actually it should be start. No. Start is, what is start? Oh, start is the number of ones inside. So start is probably the value, but not the index. So we want this to be, yeah, array of index -1. Of 0? Yeah, okay. But only if index -1 is greater than 0 and index +1 is less than. Okay. And then now we also want to have something to binary search again, so we maybe replace. Okay. And then now we also do a binary search on the replacement. But now we have to be careful. This is so awkward. I think this has to be true because otherwise we can't replace anything anyway, so that's fine. So then now we try it again. How do you do the intersection? How do you do the intersection, Larry? I mean, I don't even know the other code is right 100%. I mean, the idea I think is fine. I think the ideas is nothing interesting about the ideas, but no, this isn't quite right because things do have overlap. I have to be careful. I mean, I guess what I'm doing is implicit things, right? So we can just put in the ranges and that'll be fine. Okay, actually that's smarter. Okay. Then now here, this is the beginning index, and I guess this is the starting. That is the, this is just, okay, the update, but this here we want actually the indexes. That's the value, and then this is just this plus L, maybe -1, but that's fine. And then now we can take a look at this, and this is gonna be like a 10 wrong answer problem because I'm just too lazy to kind of think through everything correctly. Honestly, and we'll do the same thing here actually. So we want to find something where the range is totally inside. Okay, that's fine, right? Okay, then we just do a query. If it's inside, then the query on the left or right. Otherwise, we have to keep track of the boundaries. The boundary is going to be okay. So if index -1 is then purple L index -1. The right boundary is going to be the chopped off. So L from L to this. That means that you have from left to that, so it's inclusive maybe. Yeah, okay. And then this is the 0th element of the next element. Yeah. If you search for right, it'll cut off. We go to the previous one to at the left, but we want it on the right. No, we want the left. I don't know. This is so easy to mess up. We want the left side, so we want R minus. Something like this. I don't know. Let me get at least examples right. NS 116. I thought I would, for that one I thought I was gonna manipulate it more, that's why. From 29. Oh. Okay. Mm, 160. Is that possible? Oh, I guess so. What did I say start was here? Start is the number of ones in the inside. What? What am I doing? What is start here? I guess there is no start. No, there is no start. For the purpose of this, it's just the value that's inside. And then this is the replacement. So actually, this is wrong. It is actually yeah, this thing, I guess. Huh? How do I get this consistently wrong? That's wild, actually. Alright. This is really wrong, which is not great, actually. Why is it 3? Oh, wait, no, I'm looking at the wrong thing. Okay. I don't know if I have enough energy to work on this problem. This problem is pretty stupid. Oh, this contest is pretty stupid. Well, this problem is pretty stupid. It's not that interesting. It's just case analysis and so easy to get wrong. I feel like I'm not learning anything here. So, because you have tier, you cannot remove this one. So that's why this is wrong. But do I have the energy to fix it? I don't know. Okay, so yeah, the contest is over. I'm observing a little bit. Okay, that's okay, 03. Let's actually print the thing real quick. Okay, so we put 1313. That's not very correct. It should be. That's really wrong, actually. So okay, I mean that's. Hopefully that gives us a fix. But okay, so removing this gives us from 1 to 3 is not right. What am I doing? Huh? What is this doing? So you have this thing. It opens here. Oh, the indexes. No, this is 0. No, it's not 0, but what is it? What did I have it before? It's the start plus. Okay, so you definitely have this thing. And this is the starting index. What is starting index? It's not index, so it is just like current minus this or something. It's probably the start to get it back, and then this thing is just current plus L. Yeah, current plus L sounds right, actually. Okay, 0, 3. I mean, it should be 0, 2. So maybe I'm off by 1, but maybe that's fine. 2, 5, 2. Yeah, okay, we're off by 1 here. That's fine. Length, I guess that makes sense. Length is not the right inclusive bound. Okay, so we have something like this. Okay, so now we debug rebel, which we clearly was wrong here. We also, this is wrong. We want current minus this thing. Okay. Okay, so I do want to debug this part first. Okay, so 0, 3. Is it on this part? Alright, let's see if it is on this code. Okay, so it is definitely just because of this code. Okay, let's not handled outbound stuff yet. Though maybe we have to. But I think for that example, it shouldn't matter. Okay. So the outbound stuff is what's getting it weird. Okay. Well, not just that, because we have to 2, 1, 1, 3, 1, 3. 1, 3 we have. That's weird, maybe. Maybe not. Okay, so 2, 2. Is that right? I don't know that it's right. Two, 2. Oh wait, no, that's right. 0, 1, 2. So no, yes, that's roughly right. But and then we query inside, which is definitely not right, because that's based. I see. This form is just silly. Because it's just a lot of tracking. Okay. So let's see, right? It's already 9 o'clock. Jeez. I spent 2 hours on this contest, and it's not even that interesting. Okay, so how am I processing this in a better way? So I wanted to put it here, but it is not good enough to get it not out of bounds, right? So we want to say that anything that starts here is no bueno. So how do we do that? We look at here, we go, okay, we want to start 1, 3. We have a range from 0 to 2 and a range from 2 to 4. So actually it should be out of bounds, right? So we cannot query by the ones. So this is wrong. Because we bounded by ones, but the replacement is actually even beyond that. Alright, so we need the next one. We need the next one. Okay, so it goes 2, 4. So search for 1, 3. The 1 gives us this one, and the 3 also, well, it gives us 2 to the 4, but then it goes out of bounds, right? Yeah, because it overlaps. How do I track it in a good way? Can I do the queries backwards? In order or something? Does that even make sense? No, because it can overlap. Yeah, this one is awkward to do on a query basis, so it can overlap. Okay, so you want to, let's say you want to do 1, 3. Right, maybe we need a segment tree on the queries itself, or not on the queries, on this array. Right, 1, 3. What does that mean? 1, 3. Well, it overlaps, but it only overlaps with one thing, right? So you have all these segments, they overlap with one thing, you query by some amount, and yeah, okay. 1, 3. So you keep going to the left until there's no overlap. Okay, and then here, instead of this thing, we'll just update by the index of the array. Maybe that's fine. Yeah. And here we get the first thing. Double check that it's in there. Okay, so then now REPL has the thing, which is to say if while o left or o left is less than L, then o left we I mean, this may out of bounds actually, but yeah, I think maybe that's fine. And then now instead of all this stuff, or maybe just here we have to while and is less than left. What if it's or right rather? If the right, so that means if it intersects, let's say inclusively, then L index well, and then go to 0 and right in the if the left side how do you check those intersect? Too many visualizations. Okay, so you bind the search, so it intersects by definition. Actually, I guess I don't need all this stuff, right? So okay, so then now while this is so let's say we're searching for, in this case, a 3. Search a 3. About we go subtract by 1 to go to the previous one. Okay, no, everything should be bigger, right? So that should be fine. Because we're searching for the right end. Yeah, that should be fine, I guess. Yeah, maybe that's fine actually. Huh. And then now, yeah, we can just query now on the left index and right index. Alright, let's see if that fixed it a little bit. Okay, we're no longer getting a lot more wrong, so that's good. Maybe this is a thing. I don't. Hopefully this fixes some stuff. Alright, that's really wrong. Why is it so wrong? Is it here? No, that's definitely a source of wrongness. Let's see if this. I think this is actually maybe good, but I don't know. Maybe just not wrong, but I don't know if it's good. Okay, so here it is saying that basically the left index now has no overlap. So we want to go back to one overlap, which is that if the right side of the thing we overlap. Okay, why is that giving me a 7 then? Next is 4. L is 0. So we want a number that doesn't overlap. That's fine. So 1, 3. So the 3 has to be, yeah, so we go out of bounds. Then now we try to get back inbound, right? For 0, 3. Maybe this could be part of this actually. They should only have 2 things though, so maybe that's fine. Okay, so that's not fine. 1, 3. Am I doing the math wrong? What we want is also this math is wrong because it gives me the number of things but not the number of replacement, which is not quite right. Right, so this gives me the range and I don't even know if this range is right. This range is not right. This range is not right. Because you need to count the number of ones inside that range. Which we can keep track of actually, so it's fine. No, but then, yeah, I don't know. 03. It's definitely not right. This is the length of the next. Given this one. Is this, that's why. Yeah. It just happened to cancel out. Okay. Now we want the number of ones. And then now yeah, the ones is not that important because we have to do a prefix sum anyway. But okay, so let's say we have our R, we have our index. Maybe I'm getting confused about what I'm doing. I'm searching. Okay, so we have this, right? It overlaps. So we binary search for the L. So in this case, we're searching for 03. Oh, okay, maybe that's why. Maybe we should not have searched for L plus 1 in this case. Okay, so now it's search for 02. Okay. And now, and this one is not great. Alright friends, I'm gonna take a break. I don't usually cut from video, but I'm gonna take a break, so yeah, hang on. There'll be no break to you, but I'm gonna just stop because this is just an annoying bomb. I don't think it's anything hard. This one is not hard, and I don't even think Q3 is that hard, but it's just certain specific things, and I need to take a break. It's been 2.5 hours. So yeah, okay, hang on. Yeah, so I'm back to doing Q3. I'm going to take a break again before doing Q4. I think Q4 is fine. It's just that it's a lot of. I don't think it's a interesting thinking problem. It's just an implementation problem, right? So, alright, BRB. I mean, you'll see me right here anyway. Alright, I'm back to grind at this Q4. Like I said, I think this is a dumb problem, but let's play around with it. I don't know anymore. Okay. Yeah, I think it's just. So we have these segments, right? And we want to say, okay, we have 1, 3. Well, I guess even in this case it's 0, 3. Binary search on the 0. We match here. We will take. Now we don't want. Okay, so that's why, because we don't want any intersect. So we actually want to binary on the left side or on the right side. That's why I was getting confused. Okay, and then the right index. What do we want to do? I mean, this will give us something that will be, yeah, that should be fine. That means that there'll be no overlaps. Okay, but then now we want to search for start, which is, I guess, a little bit trickier. Because we want the left side to be bigger than the maximum thingy on the right side. I guess that's the part that's a little bit weird, and maybe I have to go back to fix the other parts. I don't know that I don't remember them anymore. It's been like hours ago at this point. I mean, actually, it was like only an hour ago, but it just feels like forever. But okay, so how would I mean, I could set up another data structures for it, but yeah, maybe we should. Let's do it. So this is the right side of it. So then now we can just search for the right side. I forget what does this mean? Replacement, I guess so, yeah. Okay, so then here we do. So then that'll give us the right index. So we search for the left, that'll be so then it'll be our index -1. I think this is no longer needed. Let's comment it out instead. Yeah, but our index so we have to go. Actually, in this case, we want to do our index -1, right? Our index -1 should be the one where. Okay, let's think. So left side, it goes outbound, and this should be right. And then -1 will be in. So actually, yeah, maybe I think that's fine. Okay, and then that should be good. I mean, it's not enough because we have to do the things, but now I think this is in a better place, because then now you can look at up to 2 things to the left is fine. Is it only up to 2 things? So let's say you have a huge overlap. Your right side. Yeah, so these are the things that go. So then now, I know. This doesn't make sense, actually. Okay, so we want things. No, we want overlap, Larry. We want overlap, just not. We want inclusive overlap, not okay, I think I messed up again. Okay, so let's take about the left side. Alright, so you have 0, 3, you have 0, okay, so that's fine. And now we want to search for the right side. This will give us the next index, so yeah, so we have to do this. And that is fine, actually, right? Let's see, double check that it doesn't mess us up. Okay, it does mess us up, so that's a little bit sad. Why? Because 1, 4 will give us this one, maybe? Let's see. One 4 gives us 1, 2. Oh, no, then it's just 1, 1. And it's 2, 2, 4, 2, 2, 4. Oh, what is it? 1, 4, 4. We want this to be inclusive. Is that not fine? What does 2 to 4 mean? 2 to 4 is from here to here. So 1, 4 is from here to here, right? 1, 4 is from here to here. 2, 4 is one of the segments. That means that we have 4. Why do we? Oh, because I don't subtract. So this is the segment, but I don't. Okay, I have to subtract the prefix. That's all. Okay, yeah. So the existing ones. yeah, you have to subtract. No, I mean, yes, but what we need is that this to be the delta actually. So, okay, so query, that means that the update, we want to subtract the t. Okay. Okay, I think we're in a better place. Okay. I mean, I expect this kind of problem, or this kind of thing when I kind of dug into it a little bit, but, okay. Okay, I mean, I'm pretty happy about this. Okay, then now we want to do 0 to 3. 0 to 3, we have 0, 1 is our thing. So we take the best out of these. Is that right? It doesn't feel right. Oh, is it all index? Or, okay, so it just takes, okay. So it takes this, which is fair, right? Why does it think it's 3? 0 to 3. So it gets 0, 0. So there's 3 things in there. 0 to 3. So it thinks the beginning is 2. Okay, let's just print it out. Start and this ring. Okay, so I think of infinity is pretty bad, but okay, so starting this 2 from 0 to 3, I guess that's true. Okay, so that's fine. That means that the, well, is it from 0 to 3? The answer should be here, and this actually should give us 2 more. This should give us 2. 0 to 3. 0 to 2 as a search from 0, 0. Why? This index is wrong. Index on Webbo is not the index on... Yeah, okay. I'm just being dumb. So this is actually not this. It is the number of ones. But this will be a good upper bound. It's fine. I'm not going to worry that much about it. So length of Webbo -1 maybe. Okay. Alright. So okay. So we solve a bunch more. So now we just have to keep going. Like I said, I expect like 5 wrong answers from this, and that's fine because I know what kind of problem this is. And during a contest, I don't know if I would be able to get it because I don't know that I would expect to get it, frankly. But I knew the problem immediately, which is maybe fine enough. Okay, so then now this one we have 6 for it here. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1 to 5, right? Yeah, 1 to 5 here. Okay, and then the answer is 6. That doesn't make sense. So okay, 1, 2, 3, 4, 5. Am I looking at the right problem? Why is the expected answer 6 when there are only 5 characters? Am I misreading the problem, or am I just like not reading the right problem? Huh? One, 2, 3, 4, 5. So there's only 5 characters. How do you get the answer 6? Am I really misunderstanding the problem this entire time? Huh? Wah? Wah? Is 4 the right answer? 4 is the right answer for... My answer is 4. Expect answer is 6. Am I looking at the wrong problem? Also, it's nice that they know it's a problem. Right? How do you get... Oh. No, but still, how do you get 6 from 5 numbers? Am I going nuts? Have to... Huh? I mean, even if it's one index, it doesn't even... Is it one index? No, because there's a 0 index. But even if there is, there's only 5 numbers. What? I don't get it. I'm asking my chat. Is there, do they explain it? Oh. Oh. I guess they do explain it, so I just didn't read it. So they want the active... This problem is so much easier. I'm dumb. I mean, it's still not easy, but it's easier. Maybe? I don't know. I mean, okay. Definitely got it wrong. So I don't know how wrong am I, because I've misread this problem the entire time, and I've like after 2 hours. Okay, so I have to reset my mind and try to think about this thing, but okay. So so this is the replacement. The start. I mean, this we don't even need this start anymore, in the sense that start is and the best will always be just... I mean, maybe that's the only difference. I don't know. Right? Is that this is going to be n plus 1, or total. Right? So, what's it? Right? Maybe, I don't know. Maybe I have to make more changes, but okay. I mean, like, I don't know. Like, I mean, that's just bad. Okay. I mean, there might be other things I have to do, but it's fine, right? So, okay. So, I think it doesn't change anything, honestly, that much. At least not for this part. Maybe I have to go back and change the other thing. But okay. So we have this. So we put the 1, we remove it, it's 0. Was it 5 before I fixed it though? I don't think it should have been 4. Anyway, okay, let's debug this, because I think let's debug this, even though it's doing the wrong thing, because I don't think it should be 4 in any case. In this, because this should be 5, right? I just was confused, because you should put the 1, get rid of the 0, and then you have the 5 zeros. So the increment should be 4, and we should be happy. Okay, so here we only have 1 6, 1, 2, 3, 4. Oh, because it goes all the way to 6, and then now there's an overlap, right? Okay, so we might have to be more careful about overlaps. Okay, that's fine. So that's why this is a good thing for us to debug. Okay, I just have to remember. Okay, well, I mean, I always knew that I needed to do overlap, but I think this is the overlap part that we have to fix now. This is the non-overlap. No. I need something here too. Okay, so this is as good as it gets. Fine, right? Because it goes 0, 1, so 0, 0. So this replace. Wait. Does it even print out? It does, but not for 1, 5. Wait, is it? Maybe I don't know actually why it's printing, or for which query this is printing. Okay, so that's expected. With 0 to 5, it doesn't fully overlap, so that is also expected. Okay. So far, actually, we did expect this. It's just that I couldn't wrap around the expected answer for a while. Okay, so yeah, because then now we have to take account the boundary stuff, right? So then how do I do the boundary stuff? Okay, let's assume that that's right. And then now the boundary stuff, so we search on the left. Right, we search for the 0, we see this. So then it is just, yeah, and how many ways can there be? There should be, so there should be at most 2 chunks, so you should only at most do like 2 extra work, or maybe 3, I don't know, but let's see. So while I don't think I ever, where do I use Sweeper? We don't really use it. So let's actually get rid of the right part, because we reuse it anyway, so we can just fix the binary search a little bit easier. I mean, we need to rename some of these, but it's fine. Let's just make sure it still runs. Okay. Why is that in red? Okay, no idea, but that's fine. Okay, so then now, okay, so the L index, what is the L index? L index, so that means that this is going to be the first one. Okay, so what? And I mean, I guess it doesn't really matter, but so okay, so while the right side overlaps, so while is, yeah, then we have this thing, which is just the number of so we can all convert it all to things, so it's going to be all minus our index is the number of items in it, maybe off by 1. Is it? Yes. And then we subtract out the stuff in the prefix sum, so it's prefix of r plus 1 minus prefix of I think that's maybe right. Would be more right if I increment our index. Okay. What is this? What is this? Oh, that's just. Actually, I have no idea what this prints. We print this thing. Oh, that's the. Oh yeah, it's no longer the thing anymore. Okay, that's why. Okay, yeah, whatever. That should not be right. We need some print love here. So we have this query. We have this thing, and then the existing thing. Okay, so for no, not for 1, yeah, for 1.5, we have 5 things there, 1, 2, 3, 4, 5, minus 1 existing, so that's a +4. 4 plus the start of 2 should be 6, right? What does this say? So +4 plus start. Start is 5, which is very awkward actually. No. This is start, right? Start is 1. Oh, right. I didn't. I forgot that I totally meant to do this. Okay. Silly past Larry. All right. Now we definitely overcount, but that's fine, right? Is it overcounting here? I guess so. Yeah. Okay. So where are we overcounting? We overcount. The left side of the thing. Yeah, that makes sense. But we only. How much are we overcounting? Or why are we overcounting? Get rid of this for now. Let's actually bring back this thing so that just have a separation, but also just print. Okay, so we have 1.6, right? So here, start doesn't change, it's always 2, okay. So okay, so we are doing too much. So here we have, what's it, 1.3, 1.3. We have 3 as an overlap, but that's, oh, I see, because the 3 overcounts the 2. Okay, fine. The new left should be okay. New right should be min of right. Okay, right. Still going too much, hey? Oh, I only updated the print statements. I am blind. It is very late. I've been doing this for hours. I was like, eh. Well, it wouldn't have done anything even, because it's just a print statement. Okay, so still wrong, but that's fine. Okay. So it looks at 0.2. Overlap is a little bit awkward, though. Oh, wait. Let's see. What are we looking at? Okay, so it goes 0, 0, which is actually also not right, so that's good. Maybe. Oh, this is good. Okay, fine. Okay, what am I putting? I'm putting way too much now, but okay. So 0, 3, 0, 2. So the lift of 0 to 2 is going to be 2, which is right. Right, so that's... Yeah, wait, what? Oh, no, I'm looking at the wrong input. I don't care about 0, 3. 1, 3. Okay, so you have 1 to 3, right? We have no overlap. Well, we do with the 0, 2. But that's not, should we, okay, 1, 3, yeah, it doesn't overlap here. Okay, that's fine. That's what I expected, actually. I was like, it doesn't make sense to overlap with 0, 2. So it overlaps with 2, 2, 4. 1, 3 overlaps with 2, 3. Oh, right, because it's the 3. So 1, 3 overlaps with 2, 4. Does that make sense? The problem is that you cannot make the move on 1, 3. That's why. You cannot make the move on, well, either ones. So that's why you cannot overlap with 1, 3. It's so annoying. Okay, so how can I fix that? Basically, we want to overlap. Is it just our index? Where's our index? 1, 2. What is our index again? I'm so... Okay, so we bisect it on the right side. So if it's 3, then this is not going to be inclusive. Okay. Okay, I see. So we actually... Okay, so we want it to extend, but only if the ones are not on the thing. That is the hard part. Okay, so that means that for this, maybe we need to keep track of where the ones are. This is so annoying. Keep track of where the ones are, right? So that when we do the overlap, okay, so okay, and we have to do it, but how do I do it? You have 1, 3. So the block of ones, yeah, I mean, I guess we just have to keep track of it, right? it cannot be. Yeah, because basically you want to do it cut off, but the cutoff only extends on this if. Yeah. No, I mean, I think this intersection doesn't make sense. I mean, it makes sense, but it also doesn't. If I get rid of it, it kills the other stuff, right? But what I want is flip that 1 1. Yeah, maybe that's fine actually. Maybe I just keep track of the one left. So on the left intersection. Right. On the left intersection we want to do the current index. So current index is just current, right? So then now we only consider this if inside this segment, if do I even need to? If n left, yeah, maybe not. Maybe it's just if what was it, S? Doesn't solve this one though. What is it again? 1 3 1 3 2 3. Oh, because it's overlapping. This is a very weird overlap. But 2 4 is this one. So then coming from the left side doesn't make sense. That's why. Because you're doing 1 3 1 3. Okay, so we have 1 3. The overlap is 2 3. Two, 3. Okay. Now, okay, so 2 3. Okay, so we have 1 3. The overlap is 2 3. But it is no bueno because we cannot press the 3 here, so that this doesn't do anything. I mean, they're two numbers, but it doesn't matter because we can just set this as 0 and this will still be true, which is that 1 3. You have a 2 4 segment, say. But you can click on the 1. I mean, I guess this is true, but is it good enough? I don't think this is good enough, by the way. But I am very tired, and if you've been watching this, this is the first submission, which is actually surprising. So I am going to YOLO submit it. Just get a wrong answer. It matched the input, so that's good enough for me to get, you know, get triangle. This is pretty sad, actually. What is it? 154. Yeah, I mean, I didn't reconsider this part, so that's fine. Because I don't know, I'm tired as hell. But okay. Like I said, I expected many wrong answers, but I didn't even make enough progress to have the first wrong answer, which is really sad, actually. This doesn't even make sense, does it? It shouldn't be this. Okay, but yeah. Let's get rid of this for a second. Let me see. Does this give me the right answer? Nope, not for this. Oh yeah, because we have to trim it. And I don't think that's quite right, but I just want to see if it's not error. Oh, okay. Okay, what does that mean then? Okay, so if we go out of bounds, then that means that, yeah, I mean, that's fine. Oh right, it's just equal to O left minus 1, I guess, whatever. It gives me a default answer. Not confident. Oh, let's get another wrong answer. Let's go. But that's just like a stupid hack. Shouldn't time out though. I don't think so. Unless I do something silly. Unless this times out. But I thought this should only work for 2 elements. I don't know. Maybe that's still a good sign though. Because I actually expect. Ooh, okay. I mean, I don't know why that took so long to get a wrong answer on like a 4 element thing, but maybe Leetcode just having some issues. The contest, the weekly contest is about to start. I haven't been that far back, so maybe I'll take a break because the server issues might happen. But okay, so here we have 0 0 0 0 0 0. I think it says 3. That's not right at all. Why is that? Dong dong dong. Does it do anything here? So 0 0. What am I putting anyway? 0 0 0 0 0 1. So 1 0. So this. Yeah, that doesn't make sense though. Maybe it does. I don't know. I mean, why am I doing it? Not that it doesn't make sense. It's just one element should not be. How did I get the other one right though? Like 2 2. Oh, 2 2 is no 2 2 should be. That is wild actually. Surprised that 2 2 is right, but this is wrong. So 0 0. Okay, so we have 1 0, but it should not be here. Oh, wait, no. What does the 2 2 thing say? It doesn't even go here for some reason. Maybe I need to add some sentinels? I don't know. Maybe that's fine. Let's oh, can we do that? Why are these answers so wrong? That's what I want to know. Like, I thought it would just be everything plus 2, which is true up to here. But I don't know why these are so weird. Maybe that's a smell, actually. Because you're not supposed to flip them anyway, but... Right, maybe I will do it this way. Maybe this way is a little bit cleaner, I don't know. And then we just do this -2. Of course it's still wrong, but now it's wrong in different ways. Why is this wrong for... What is the input here? 1, 3... Oh, the indexes are wrong. Okay, fine. That makes sense. For the queries, where are my queries at? Yeah. Okay, so maybe it's wrong because of that. Hopefully that makes sense. Okay, so this looks better. Still wrong on here though, so maybe it doesn't do anything, and I'm just kind of shifting the thing a little bit. Okay, fine. Get rid of it then. Or that. Okay, so why is... Because we only overlap on the left side. We don't do any overlaps on the right side, which we have to, I think. But I just don't do it. So, okay, so 0, 0, 0, 0 overlaps with 0, 2. Okay, so there's 1, 0. So we just count the number of zeros and the number of 2s, but... Oh, okay. So if there's no ones inside, then we can do it, right? So if okay, yeah, fine. Oh, I have a subtract 2. What? Did that not? That's weird. Is that not the case that this is oh, not has to be greater than, not just greater than equal to. Okay, looks good. Looks good. Just click submit. Yeah, another wrong answer. It'd be nice if you don't take that long though for a wrong answer. I think there's a contest in 3 minutes, so I think I'm gonna take a break anyway. Maybe get some food, because contest time is probably gonna be a mess. So yeah. Yeah, maybe I'll take a break, but let's take a look at this one real quick. That's how they get you. What am I doing here? So okay, so you have this one, you have 2, 4, 0, 1, 2, 3, 4. I think it's 3. Why do you think it's 3? Oh, because okay, so it's 2, 4. Yeah, cannot highlight correctly. Okay, so 2 to 4. It thinks it is 4. Would make sense. But it is 3. But I put 3. Why did I put 3? I'm happy. Oh, jeez. So it's not because of this, the overlap thing. There should be an overlap though, so why doesn't it go there? Okay. Alright, I will take a break. I'm back again on a debugging trail. Leetcode contest is actually still going, but like the weekly one. But for like the beginning of it is over, so I'm trying to debug this. Yeah, so I'm giving a 3 for this. Yeah, just grind it out, you know. I don't think there's anything hard about this. Is the annoying part, but it's just a lot of edge cases, and I think even very good programmers are telling me that they're struggling. So we'll say 0, 1, 2, 3, 4. So we have this. So we convert it to a +2, but it's giving me a +1, I guess, probably, right? So yeah. So there should be somewhere in the overlap thing. So 0, 3. Am I looking at the right problem? No, I'm not looking at the right problem. Okay, so yeah, it's this one. Is it this one? Yeah. But it's not this input that is debugging. It is 2, 4. So 1, 2. Why is it not looping at least once here to do the intersection algorithm? So okay, so it's doing 2, 4. The thing is 1, 4. So the 4 should overlap with the 1. That is weird. I guess maybe just have this. 2, 4. L index is 1. That means that the 2 is already the 2 is already going out of bounds, so that's why it's not seeing the 1 at all. Okay, that's fine. I think I did know that this was gonna happen, but I don't know, maybe I was just stubborn about it. We just have to go through the right side, right? So here maybe we have our index is greater than equal to 0, and basically we know that we want overlap on the right side, so we have 2, 4, right? But the intersection is 1, 4. Still a little bit awkward, but I think that's fine. The signs are a little bit tricky to get, and here we actually want the right index. So okay, so if we're intersecting on the left side, then the left, if the left, okay, if the right, if the thing is, how do I write this? Okay, so here the logic is that the right side of the current thing is here, right? So that means that the left side is greater than or less than this. I mean, it will always be less than this though, right? So what am I doing? So okay, so the left side. Okay, so it goes to right? Our index is on the right side. So then our index will contain the thing. And then it tries to intersect. Yeah, no, this should try to intersect to the next one. So this will also return a 1. Okay, and then maybe this, and okay, so then now the last one, if it intersects with the left, but the left just keeps getting smaller, right? So that's why I'm struggling. How does this work? If the left of the thing that we're doing, if the right is, how does it keep, why does this not keep going then? confused. Maybe it's just by this part. Maybe that's why it times out looking, because this looks very weird. I mean, it just looks like we do everything. So this, I think this condition is what's confusing me, because it doesn't seem to want to be, doesn't make sense. That's what I'm saying. So what this should be is that, okay, so intercept, eventually, oh no, this is right. The R will stay the same, so then it, when we increment, okay. So then here now, we, I'm doing a lot of dancing. Okay, so here we have the L with the thing. Oh no, I'm moving the wrong thing, that's why. So okay, so let's say we intersect. Now we decrement, then the R is, so while the R is greater than or equal to the L. Okay, I think that's right. And then maybe something like this anyway. Okay, then now the left is going to be max of this or the L, and the right will be, yeah, the chunk that we care about. I think that's right. Maybe. It fixes this, but we'll see if it's actually right. There can't be that many cases for me. Oh, oops. That's funny that that's routed code, that it doesn't go. Okay, YOLO submit. I mean, I still expect this to be wrong, honestly, but that's fine. This is such a mess of a code. I don't know why it takes so long to be wrong though. Just be wrong and fast. Like there's only 5 things. How many test cases are there? Does it tell you? I don't. I mean, maybe don't. Oh, this. I was looking for the more detailed page. Does it tell you? Maybe. I mean, maybe during the contest it doesn't, but maybe now it does. Maybe I don't know. Oh, 307. So there are a lot of inputs. I don't know why it's still so long though. Okay. So here we have 0 to 5, so 0, 1, 2, 3, 4, 5. Output is, oh, we overcounted. What are we overcounting on? That's interesting. Dun, dun, dun. All right. Is it the outbounds? Not that one anyway. Okay, so still not that one either. So it's one of the thingies. What is the optimal move? The optimal move is just converting this one, right? So why is it? Okay, so it's in here somewhere. So it's probably this one even. Right? Let's see. Let's put it out real quick. We're looking to solve the 0.5 case. Actually, it's here, so it's nice. Okay, so we have 0.5, 0.1 on the thingy index. Okay, fine. We have to bring it back. Over 2.5, 1, 2, 5. Okay, that's fair. And then we have, and our query is 0 to 5. Our thing is 2 to 5, so it's not, well, I mean, it's overcounting, so it's not like, that's weird. Maybe. Actually, this part doesn't make sense. So 0, 1, 3, 3, so 3 and 3, so that's 6, right? So something else is, okay, so I did this one at a time, but maybe I needed both of these to, for it to be correct. No, so where does the 7 come from? Oh, is it this one? Okay, so what is this part? Oh, the 0 max 0 1. So okay, so why is that wrong? Oh, this is the original part of the code. Okay, that I haven't seen in a long time. Okay, so max 1, or min 1. No, min 1 should be fine, right? Min 1 should be 1. Okay, let's see. Let's print it out. 1 min, 0 max. Doesn't seem like it could be wrong, right? Alright, let's print out. 0, 4. So max 0 is 4. Why would that be 4? Did I just mess something up real quick? 0's left. Okay, let's see. 0's left, 0's right. Okay, so 0's left is definitely way wrong. Okay. There's a lot of places could be wrong. Okay, so is this? So what is this saying? Okay, so we have the number of ones. So this is the index of the thing with the 1. So then 0 and then L, right? So okay, what is? It's a 4? What? We're going to print out ones. Don't know anymore. Okay, so there's on that 4. So we binary search on. Oh, this is L plus 1. That's why. So 0 sub left. No, I mean maybe, I don't know, but should be 4, and then there's a 1, 1, 4 there. We search for 0 to 5. The overlap on the left side, it goes from 4 to 0 for some reason. When it should be from 0 to 5, but it goes to the next one. So it should be the, this is the one that doesn't count it, but because I assume everything to the left of the last one, but that's not true because of this thing. How do I fix that? So it is searching for L plus 1, L is 0, so it gets to the 4. Wait, what was my logic here? I don't remember anymore, it's been so long ago. Okay, so the logic here is that we start at the 1 and it goes that long, so everything to the left of that 1 would be 0, which there is 1, but there is more. So we need to bisect left more precisely, because here we check the one that is direct. Okay, yeah, we check the one that's directly on L, so that's why. Okay, fine, maybe. So here is a, okay, so here we do it again, I guess. this time with the L instead. I think this should be fine, maybe. Okay, did I get everything right? Okay. Okay. But now we probably should fix this one too. Right? I don't know, maybe. I'm lazy, so I'm just gonna go that. I think that's wrong, but I'm just gonna wait for a case to show it. Because this doesn't make sense. We probably have to go to the next one, which is fair. How will I fix that? Let's just do this. Yeah, okay. So then now we have 2 to 7. Output 4, expected 7, okay. Which part of it should be? I mean, I see why this is wrong, but I don't know the thing for it. Like, okay, so it just means that I don't chop it off correctly. There should be one of these intersection things, right? So 2 to 7, or 2 to 6, or 0, 1, 2, 2 to 7, or something like that. 2, 3, 4, 5, 6, 7. Okay. Yeah. Something like that. How does that change things? Why did I put 4? Is it because I don't do anything here? This is just so annoying to debug. Really impressed on the people who did it. So 0 to 9, okay, that makes sense. Okay, so we 2 to 7. 2 to 7 doesn't even get here, so I think that's definitely. Is it doing a double thing? Oh, because it's cutting off at the left and the right. That's why. Maybe? Right, so 2, 7. Yeah, it's cutting off at the left and the right. Actually, I did not consider this, even though maybe I should have. But, okay, so let's say we had these two things again. How do I even fix this? If this is inside a segment completely, right? If LR is inside a segment completely. If that's the case, then what should this be? 1 and 0, okay, that's fine. Wait, is it true though? 5, 9, no, that's fair, okay. So if this is the case, I don't think it should be, I mean, maybe I'm wrong. It should be only a couple. like the left index is gonna be that far ahead, right? Because of the pigeonhole, I think. So then now we just do the same thing, right? Just the intersection formula. And maybe that's right. And then, is it actually right? I don't know, honestly. Let's see. This is really bad code, but gets me the right answer though, so I don't know. Is it good enough? I still don't know. And it might even time out, which would be sad. I don't know which one I'll be sadder by, timeout or wrong answer, but I guess we don't get a chance to find out. 338. Maybe I need to rethink this, but I mean, I think the idea is still not that interesting, so I don't know. 3, 4, 5, 6, 7, 8. So you probably want the island in the middle, so it's +2. The base is going to be 8, maybe, but it's +2. So it's 10, I put 11. Why is that? What is giving me the 11? Does this fix it? Nope. Does this fix it? Where does the 11 come from? Nope. Should be directly inside though of something. So I feel like it's not one of the overlaps. So I'm just counting somewhere wrong. Is it this one? The query? What? Okay, I'm confused, but okay, fine. Oh, right. Nope. So is this one max thing again? Okay, so, huh. Oh, this is the thing that we said this is probably wrong, right? Did come back to harm me. Okay. Okay, so this is the case. Maybe. We want to, yeah. Where is it doing it? 165. I guess that's where I expected. But okay, just actually think through the first principles, Larry. What is this one? Right. It's okay. So okay, zeros to the right is going, and we can actually pre-calculate this. I don't know. Maybe we should have. No, I mean, not really, because you also can cut off at the left. Okay. Do I need to care about things getting cut off at the left? Okay, I don't know. Okay, so right is the current, right, and then this is the last one, so this is the index of the last one, right? Maybe after -1, maybe that's it. Nope. So this is the index of the last one. What do I print furthermore? Which one is it? That's one. Is the 3.8 one. So 3.8. -1 is always a bad smell. 0's to the right. So that okay, let me run it again just to make sure that I didn't. -2 is definitely a bad smell, so that means that we probably have something really wrong there somewhere on this. But in any case, this thinks that this is 1 where it is something like this here, and there's no 1. Alright, that's actually 3, 4, 5, 6, 7, 8. So there's no 1. The 1 chunk. Oh, because we counted from the right. I guess that's fine actually. If it's negative, I mean. I don't think it matters that much, but shouldn't change this one though. But here we have 1. That 1 is more interesting. Why is it 1? Because it thinks that it's 0, 1, 2, 3, 4, 5, 6. 6 is 1. So from 6, that's not true that it goes from 6 to 7. It goes from 6 to no, it starts from 7. Okay, that's fine. But 7 to 8 is not right. So it's off. Is it off by 1 or is it just logic error? Let's see. So 6, there's a 1 at 6 is what this is saying. So, and then 7 is going to be a 0, which is fine. And then 8, so we're not. So when we search for this. So this is fine. Maybe it should be this actually, but I think this is fine, maybe. Actually, it's just that this one time maybe can be helped in a sense that, yeah. I don't know if there's a y in zeros. Why am I so bad at everything? Okay, so it's still not the answer though. I thought it might be, but okay, 0's left is 3. Maybe that's the wrong answer. So it starts at 6, and 0's to the left is 3. Why does it think it's 3? Okay, so maybe I was debugging the wrong thing. Maybe, I don't even know if that's true. I mean, maybe there's 2 things that are wrong. But okay, so L is 3. L index sub 0. So 6 minus 3 is 3 is Y. So 0's left is 3. And if it, but no, but 2 to 3 is 1s. Oh, sorry, 2 to the 5 is 1, so that's why I'm messing it up. I think it's just a check of, yeah, if s of O left is equal to 0, then redo this maybe. Is everything right? Everything is right so far. I think I have to fix it for the other one too, as I said, but I don't know. Something like that. The reason why I don't like doing this stuff like this is because the binary search is just so awkward. And the reason it's awkward is because binary search going both directions is a little bit weird. Okay. And again, we're overcounting. What is this? 3 to 9. Here we have this thing. Is it the same input that we had? No, it's a little different, I think. Okay. So 3 to 9. Okay, 3 to 9. We think it's 10. We think it is, I don't know. We think it's 10. The answer should be 9 because we're overcounting one. Why? 3 to 9. Or more importantly, is this the reason why? I don't even know. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's okay. So definitely there are. We flip 4, so it goes from 5 to 9, but it thinks it's 5. Why? Well, 6 once min 0. I mean, it's not from here, so that's good, I think. Like if we take it out, it'll still be 10. Yep. Okay, so we have to figure out where it is again. Okay, not there. Mm, 3, 9. This is such a waste of my day. 3, 9. You have these segments. The intersection. 3, 9. 3 and 7 should only have 4, right? Yeah, so this one should be fine, maybe. Yeah, just take it out. Huh, that is wild. What's wrong? Okay, so it tries to do 3, 9. Okay, that's fine. And then it tries to do 7, 9. Is 7 right? Why is there 2, 7 and 7, 10? Oh, I guess they overlap, possibly. That's why. But because of the zeros. Okay, fine. 3, 9. So then it means, what does this mean? So it means that 1, 2, 3, 4, 5, 6, 7, 8, 9. So alright, let's put that there. So it has 2 to 7. Okay, 3, 9, and 10. Okay, that doesn't actually help that much. But and left and right. I mean, it helps in the sense that it lets me know why. But 3, 9, 3, 9. It goes to entire 3, 9. That doesn't sound right. Did I mess something up? Seems okay, but unless index -1 is out of bounds, maybe. I could see that actually. I hate that out of bounds don't fix it. Honestly. Or like it should give it an error. Like I don't want -1 to wrap around on it, but okay, so that didn't fix it. Okay. Okay, let's match this. I have 3, 9, 3, 9, 2, 10. Is 2, 10 one of the things? Nope. How do I even get 2, 10 from? Why is this index -1 again? I just copied from here somewhere. Wait, why is it index -1? I mean, this one should be -1 maybe, but that is weird. Was that just a typo? Was Larry being dumb? I mean, probably, but I'm probably being dumb. Alright. Yeah, I'm just gonna leave it in. I'm too lazy to remove output. If they bug out, then I'll resubmit and remove it. I don't know why the wrong answer takes so long. Oh, okay. Time limit exceeded. Yay! I mean, we made progress. It may be that this loop is expensive, to be honest. I just thought maybe there's a pigeonhole of like 2 or 3 items, but we can check. Right. Maybe not. Maybe there's another one, but we only do like binary searches, so I don't know. Maybe just not fast enough for the number of queries. Which would be really sad because we spend a lot of time on this. That is actually sad. Okay. I just want to confirm that it is fast. Like, I don't know if it's one of these for loops or is it like actually performance. That's why I'm not super clear about it. You can see that it takes a long time for some reason. And I don't know if it's I mean, this takes pretty long, so maybe it is the while loop. But let's say I remove both of them. Is it still like one of those things? Okay, so that means that these while loops are pretty bad. I thought you only do like one thing, right? Like, why is it going so long? Because basically you're saying, okay, this overlaps with the last item, and then you just get the one before, and there shouldn't, I don't get it. Like, shouldn't this only does a few things? Let me try to assert. Okay, count is equal to 0. Something like that. Does that give me the wrong answer? Like, I thought there'll be a pigeonhole. That's why I didn't. Like, I knew that I was risky, but I think. Yeah, is this the wrong answer though? No, so that maybe there is some like weird case where, or maybe my folder is just terrible, and I need to kind of take a look at it better a bit. Alright, I mean, maybe now I expect the wrong answer because I don't know if this is hacky, but hopefully not a time limit exceeded anyway. Because in that case, at least we'll have a case to kind of play around with. We're only 20 minutes in, so yeah, okay. Alright. I don't know. Let's see. One code real quick. Still kind of slow, but okay. I'm trying to show the difference, and we have a difference. Do we have to count this to 10? Let's see if that would have fixed it. I don't think. I mean, in that case, it shouldn't be doing that much anyway, to be frank. But now it works, but why is it doing 10 cases? I thought that do a binary search. Like how it only overlaps, should only overlap like 2 things. Alright, I mean, is this right? They should just tell me whether it's right or not. I can't like, but I am gonna YOLO submit it. Even though it probably is wrong if this is like there's some like weird thing going on. And I'm not going to keep on increasing the count. I just thought there's a pigeonhole thing. That's why. But this is for if. I mean, we might have to clean up the logic. Yeah. So I mean, it's gonna. We need to keep increasing it to make it right, and then it just becomes n square. But that doesn't make sense though. Why is this weird? Because basically this is just the left and the right, and as a result there should only be one, right? Okay, well I guess maybe we can use this as an example. Alright, let's actually put the test cases somewhere useful for now. What is this part? And then let's take a look at this. Right. And we know it's wrong somewhere in the last query. Right, let's do it the last 7 to 76. Let's get the other ones. Right. Okay. Let's print this thing out. Right. Okay. So 53 is. So okay, so I mean this is what we expect the segments to look like. It only overlaps in like 1 or 2 places, but okay. I mean maybe that'll help us debug the thing. Focus on just one thing, okay. And then now, okay, let's just say if this is 100, will it work? Yep. Then why? Okay, so we're trying to find 776. We have index of 1. Oh, I mean, I guess so. What am I trying to do? So 776, we have overlap of all the rates. Okay, so I messed up on some of this. But what I wanted to do is just... Because that means that everything inside because all we care about is just the stuff that goes on the left, right? So why is everything inside not as part of something else? It's either that this part is not right. It's probably why. Okay, so let's bring it down to 5. Let's bring this up to 100 and see if that works. Nope. So I think this part is just not working right. So this part is doing the extra work. Because well, we have to go through this, which is probably true. Because I kind of wrote this in very quickly. By copy and pasting. Okay. Let's take a look. Right, so 76. We have. Where is my code anymore? Oh. Okay, right. Okay, so 6271. Okay, but we care about 77, I think. So this goes all the way, but it actually skips 71, which is the issue. So that means that we actually want this to be here. Did I search that wrong? Why is that so weird? Where's my R index? We search it by R. Oh yeah, no, this should give us the one in which the right overlaps. Okay, maybe that's fine. I don't know. Okay, now it overcounts, which is funny. Because this segment is okay. 70 to okay. What is the 70 to 77? So the overlap would be 70 to 76, right? This isn't right. But I don't. This is really awkward though. 70 to 77. We actually, I don't think that's. Oh no, this is probably right, but it's still very awkward. Okay, let's see. Yeah, that looks good. Let's get rid of this print statement. I think the other print statements were fine. I'm just going to YOLO submit again. Oh. Well, maybe I should have not YOLO submit. Which index is this? 199? Yeah, I guess. If our index is out of bounds, that means that the right of this particular one is out. Okay, well, I thought the reason why I wrote it this way is because I thought that maybe I do need to write it this way, but I just need to increment it by 1. Maybe that's fine. Let's actually at least get the one that I got it wrong first. I think they also like the inputs. Okay, well. Yeah, okay. I think we just need to write min. Okay. Again, we probably, if we're right, we'll get our output limited exceeded, or at least close to it. Maybe it still times out, but shouldn't time out now though. It might time out because we output too much, but that's also fine maybe. Ah man, did I have this? I don't know if I had this already, but at this point it doesn't really even matter. Okay. Okay, so there's this 14 somewhere. That should be a 15. Alright, fine. Let's just remove queries, right? Okay, fine. We still remove like another and okay, so it's the third query, so 1015. Nope. 121. I can. What's 121? So there's a lot of overlap things. Maybe that's why. Okay, so 121. It deals with 0 and 8, and maybe the 21, 29. Maybe that's why. These, but that doesn't. Okay, so I. Which let's see, let's just print out L to write inclusive. Where am I doing? Oh, this one. So it looks like this, that's fine. And here we think the answer is 14. Oh, let's also print out the base numbers. So it's 9, meaning that here we want to convert the 9 to a 15, which is a plus 6. So it should do this one, right? Which is 0 to 8. So it's not intersecting the 0 to 8 correctly on 1 to 21 prefix. Why is that? So it's this part, at least. That's good. So L index is 1. Why is L index 1? So this skips the 0, 8, that's why. Okay, that should be an easy fix, but I don't know why it's doing it. It bisects left on L. Oh yeah, okay, I guess that makes sense actually. So, because you have 1 to 21, it goes to 8 to 13 to intersect. But it doesn't intersect the 0 to 8. That's actually pretty bad. I don't know how that happened. Let's just put this here. I think I try to overuse things. Okay, so that means that's this minus 1, right? And then index can be -1, so we just do like that. Now it's 16. Really, just adding one thing? Oh, yeah, well. Oh, it would be right on bisect right in this case. But still, why? Why does it do an extra one? Okay, so 120. Let's see. So here it should be here. There's 0, 8. Okay, so it tries to match correctly. It overlaps on this. Okay, so 0 to 8. Oh no, it thinks the 0 to 8 is the overlap. I guess we need to do this thing here too. I thought it was just doing the other thing. Okay. Again, I'm too tired to keep on removing stuff, so if they give me output limit exceeded, okay, fine, I will remove them. Oh, we've at least some of them, not all of them. Yeah, okay. This is per problem, which in theory should be fewer because there's only like 500 test cases or something they say. Turns out we were just way sketchy on the up by once. Alright, well, that's not great. At least we are able to show that at least these two, we bounded it more tightly. Because we have a count is greater than 5 thing. This thing that slow is a little bit discerning, but is it because of here? Or is it just slow in general? I guess it is just slow in general then, huh? Which is really sad because I don't know what to do. Let's see, what because basically we're almost at the end. It's just that, yeah, this is really sad, right? So, and this is all binary search, so I don't know that there's that much more to do. Right? Like, okay, that makes it a little bit faster, so let's go. I mean, it'll still probably time out, but I'm just kind of... This is just to kind of... because I'm sloppy, honestly. Somewhere. It seems like mostly right. It's just that we have to make up for the time. And here, we kind of want it real quick. Yeah, we cut it down from 4.8 or something, right? Which is when we have 5, right? So at least that's good. Just to kind of double check that I'm not lying. Okay, maybe 4. So this definitely helps. And we only do 2. So that was our original pitch in the whole thing. Though I thought this loop would do it, but anyway, that's besides the point. Is it because of this thing? Does that take a long time? Let's see. No, so that's not the issue, at least. That's good. What's not good is it actionable now then, right? 488. I mean, all I do is binary search. Maybe there's a lot of, oh, well, I guess that's not true. There's this segment tree thing, and there's this segment tree thing. Let's see. Maybe we can just remove it real quick. Just to see whether that would be fast-ish. Or like how much performance hits. Ooh, 1 second for a query. So can I do it without all of them? Okay, let's see. We have a 0, we have a 1, we have... there's also another one here somewhere. Right? Don't lie. Yeah, there's this one as well. Okay, maybe don't put 3 segment trees. Well, I think the trees are not a problem, but the queries are. Let's see. Yeah, so okay. So I have to remove one of these to make it fast. That's actually kind of sad. Okay, what can I do without segment trees? I mean, the ideas are right. So the queries... can I do this without segment tree? This is the index, but we're creating the end on the segment trees are kind of big, is why. This one is small, I think, but these ends are not big, too big, and we only update on. Excuse me. We only update on current, so that means that we only have to care about current, right? So that's the number of groups, which is the number of things in an array. So maybe we could do that. but actually, I mean, we can, but let's see. How can it shouldn't change that much, right? It's only a lot. I guess even a couple of things matter. Let's see. If we change this the other way, does that change the performance from 4.1? So that before I committed to optimizing the other ones, I know that that one's a little bit more optimized. So it doesn't seem like it would change that much. It's just the costs that are expensive, and the queries. Let's see. Maybe I could ask ChatGPT to convert this to iterative, please. Oh, oops, forgot to paste the code. Let's see if that fixes that fast enough. Okay, let's see. I might know that there's the other one, but yeah. Where is it? We don't need to build this. It was 4 seconds for something, so it's a little bit faster for sure. And we have 2 max trees, so I should have maybe done the max version. But yeah, I could actually convert this to max version, but I'm going to just ask ChatGPT to do it, just for speed purpose. I mean, this is silly, right? So. I don't know if this is going to be fast enough though, but at least it's maybe squeeze some time out of it. It's half as fast, so man, maybe I should change my templates regardless, because it's twice as fast. How does this look? Okay, I mean, this is silly. But we got it. I mean, the idea is still very easy. Or simple, but yeah, not Gucci though. Not happy about this, but I mean, it's not that bad. Let's see, how long did it end up taking? Okay, if it wants to load, that'll be nice. 10 seconds, so even then very close. And you can see that yeah, spent a lot of time on this. Oh, and that's not even it, there's more. But yeah, that's all I have for this contest, I think. Yeah, thanks for watching, and there's all the upsolve. I'm not gonna upsolve it more. Actually, no, I lied. Let's take a look to see what other people did. I don't know if I, you know, the next weekly contest is out, but I'm curious what other smart people did. I mean, just smart people, other people who are smart. Okay, so I don't know why they make this like. There's so much frame. Just give me the code. Like, make it full screen if you have to. Okay, fine. Let's, what's it, C++? Okay, so what? I mean, we have a sig tree. Okay, so they definitely don't need. They definitely did not use 3 sig trees. So okay. Yeah, or is the delta, I suppose, the max delta? I don't know how to read this, honestly. Okay, well, I mean, the idea I feel like still is the same, but yeah, I don't know how to get this. And maybe that's fine. How did I lose the window? Yeah. Oh, wait, that's this one. All right. Yeah.